Welcome everyone. In this video I'm going to be showing you a novel way of harnessing power from a radiant energy circuit. This circuit of mine I've known for quite a few years that it has an ability to transmit power wirelessly from the DC lines. Now, we've seen in my other videos, and if you haven't seen my other videos and you don't know what's going on here in that absolute mess, schematics are always at the end. I always give everything that I do for free here, and I don't really ask anything of you. One small favor to me, and it's more for others' sake, is that you share and please like and subscribe so you can get running updates on my work. I like to give all my work out completely for free because that's how it come to me. I was given an opportunity to do a lot of this research and spend quite a few years doing it, and the benefit of that I feel should be freely shared. So we're going to be using my circuit for benefit of everyone else. If you're not familiar, please go and check those other videos so you can come up to speed. And then please come back to this one. We'll finish this one first and then go check the other ones. So we're going to be using these ferrite suppressors in today's demonstration. It's something that gets placed on, usually on AC lines, to block radio interference, so for unsensitive things like radios perhaps, or TVs, more so in the older ones. You'll find a lot of these things are embedded in the main power cable these days, so it's not something you have to go and purchase, but these ones are little clip-on ones that allow for extra suppression of those radio waves. So we've known that my circuit, when we place this coil, and this coil is very, very special in the sense that it's a particular length that allows the wires, a particular length that allows it to collect radiant electricity from my circuit when it's placed between the two wires. I'll turn that around so that it's not showing. We can just see on its own that circuit can light up when placed between the two wires, just a tiny bit. Now the reason why it's only a tiny bit is because there is currently only a single earth line coming to the circuit, and it's via that Avraменko plug there. So the red bottom of screen, red lead, goes to the Avraменko plug, comes out the positive leg of the Avraменko plug onto the negative side after the meter. Okay, so that way I can be sure that everything that's in this circuit is after the meter, so I get a true account of what's going on. Now I'll be doing this demonstration on the front of the meter today, just because after the meter's a little bit blocked up with other experiments. I won't be explaining or placing this magnetic array in the schematic because that's still under experimentation and I'm not 100% sure it's having any effect at all. So I won't go into that. These two here, these two suppressors are wired in the same way. It's just a single alligator lead wrapped around there, maybe 5 times. Right, so if you want more, if you want higher voltages out of this, you would obviously need to place more turns on there. But the orientation of this really interests me. So what I'll do now is I'll connect up my second earth, or the main earth, and we'll go through the ground 60 meters. The earth stakes are 60 meters apart, apart. Sorry, one comes obviously off that red there. The other one will go through the green lead here. I'll turn that back around so that we can get a quick look at the wattage. So the circuit is consuming, let's say 4.3 watts, 4.4, so 4.4 just then. 4.4 watts we're going to call that. I always like to call the higher amount so no one can call me out and go, oh, it was higher than that. And over time, that will come into effect. So I like to record the higher, and I saw 4.4, so we're going with 4.4. Now, the light is this one here, straight off the shelf, no modifications done to the light. It's a 4 watt LED. It is that one there, and it's 240 volt. Does it say that on there? That's really strange. You'd think it would say 240 volt so people don't go plugging it into lower voltage. Anyway, that's their problem, not mine. Anyway, that's the light. So that's the light there, and on the other side of the light, this line here goes to earth, and that'll facilitate my through earth transmission. So we know that the circuit's running because of this light here, and so we'll place. Now, sometimes when you connect this system, because you should have a switch there to make a nice clean contact, sometimes when you make a crude connection like I just did, it will go out, and now it'll bloody do it every single time just to make an ass of me. So I'll turn that back on. I was getting to the point, you should have a switch on this light here rather than manually connecting it like I'm doing, because it does have a tendency to, it's almost like defibrillation on the heart, where it'll jumpstart it with the wrong frequency. One way you can get around it, if you don't have a switch connected, is to connect some resistors and just allow some of that charge to go through. And then once the circuit understands that it's going to be doing that now, then you should be able to connect it like that, no problems. Okay, but the better way to do that is to have a switch. But when you're prototyping like I do, like all day, every day, it's more practical to do it this way, as long as you understand that the things that you're doing through convenience may be detrimental to the circuit. Like, for example, if I have the negative, again, schematics at the end, negative coming from the capacitor connected to this battery, the drive battery, then the circuit won't even turn on. So again, rather than me manually disconnecting, and then having to remember to reconnect, it's probably more beneficial to have a switch there, switch it off, and then you can switch it on. I mean, that's still manual. So we'll put that on there, that's the negative there, and that comes from that capacitor, which is charged off of the DC line through those suppressors there, those radio interference suppressors. So now that we've got the circuit connected through earth there, through the bulb, and then return, so what is in essence a SWIR system, a Tesla, one wire through earth return. Today's modern name for that is a SWIR, SWER system, single wire earth return. So without that, this light is extremely dim. I'll turn that one around again so it's not facing the camera. And you can see there though, now that we've got that second earth in place, this light illuminates when between the DC wires. And if you have a look on my old videos, you can see the one where I've got the board. This is the portable version. The old ones, the old videos will show you that I have a coil that's in line with these battery leads, and that's harnessing that power, and then that sends that back to the battery through other setups. But this was something that's, so this is based on resonant frequency. These other coils don't light up in the same position. Okay, so all the components are the same. The difference there, and I checked it again, the difference there is the length of the wire. That length of wire on this coil that lights up inside, in between those two wires like that, that is a particular length. And I will put that up on subsequent videos, what that length basically means. I'm going to have to disassemble that coil to get its measurements, or at least take the LED capacitor out of it to get its values. So I've known about the power traveling along the DC lines, you know, obviously in its conventional sense, but this is AC power, what we've got here. So I thought to myself, well, let's try these suppressors. Someone else that's used these suppressors, I'll put a link down below, a YouTuber called Crazy Ham, I believe the name is. Anyway, link below. He's also done something with these little clip-on radio suppressors, and yeah, it was really interesting stuff as well, which made me think of this. At some point I need to do the same thing, and you know, show everyone this feature that travels along the AC lines. So now if we clip on one of these, and it can be on either, so when we're using this coil, it has to be between the wires, but on this one it just has to be on either of the wires. Now probably you could argue that it's still between the wires like that, but you know, I've separated them as much as physically possible. It doesn't seem to be because of that. So we clip that on there, and now we can try the voltage. Now these are 3.2 volt 1 watt LEDs being lit up off of that wire. Now I know that it's my circuit that does it, right? Because if you place that on a normal DC line, you'll get nothing, and I'll show you that by switching off my circuit. So my circuit's off, the light goes off. The power's still going to the meter, so there's still power being consumed, and therefore still power traveling over that line. When my circuit goes on, which won't happen now because it's connected. See, this is the thing I was saying, when you reconnect this, you need to have those switches there. Circuit comes back on. Okay, so now there doesn't seem to be very much of an increase, and that's something I need to show you as well. I'll finish this little demonstration here with these LEDs, because measuring the AC coming out of this little coil is only like 1.97, but that's 6.4, and we go 3 would be the 9.6, and then it does start to diminish a little bit when we get out to the last one, but that's operating what, 12.8. So it seems to pretty well self-regulate, locks down on its own load determined voltage. But what I found really interesting is, again, that doesn't consume any power. Now, I know you're thinking, oh, well, that's before the meter, so you wouldn't know. But I've tested it on this side. As I said, this side is just cluttered, and so I'm trying to isolate that, separate it. So if I disconnect this one now, and I'll put it back in play. Oh, well, I can show you the spot. I don't need that back in play. It's difficult to do one-handed. So those two there are connected. They're on the negative line coming from the battery through the meter. If I connect our light again, so we'll check just before I do that, check the wattage, and it's still like maximum peak. Oh, I saw 4.6 there. And as the circuit drops in voltage, you just naturally expect that as well, fluctuations. So we'll reconnect this circuit. All right, so light's back on. That's a 4-watt bulb. Yeah, that's a bit confusing, isn't it? So we weren't running that through the earth before. We are now. So that is confusing. Now, something else I need to point out here. The little neon there is illuminated, and you would expect that it's meant to be receiving some sort of charge, but that is following that white line there, disconnected. Yep, another anomaly. It's a bit weird. So we'll leave that disconnected. The negative's disconnected as well, so the capacitor is not feeding back. When I place the negative on there, as I said before, it needs to be off to start the circuit, and you'll be standing there like an idiot going, I've done it, I've done what this guy said to do, and it just won't bloody turn on. Well, that's because you have to have this disconnection for that to turn back on. Right? If you have that on there, the circuit is now coming back from this second earth here. And so if we turn that off, and we have our positive line on as well, then the circuit won't turn back on. Okay, so we need to have those switches in place there. Take that one off as well. And then when you do that, sometimes the circuit won't turn back on either, unless you remove the high voltage line. So switches would be the way to go. I mean, I'm aware of this, and so I routinely, before I turn things back on, I remove what should be removed. Let's put our really, really cheaply run. Doesn't even seem right, does it? But that's running through the earth. Nice and bright. Okay, so now that we've got that running through earth, I'll put the negative onto this battery, and then I will show you connect up. We'll bypass the neon, straight to battery, so I can show you the discharge on this capacitor. Okay, now that is being charged via those little suppressors. ferrite suppressors. So that's real. Now, having this connected without the neon results in a very dim light. If I separate it, obviously the light gets brighter. If I connect it back up through the neon, we don't see a reduction in lighting. So now I can still charge that battery without losing my lighting effect. And I also don't have to worry about the power draw on these additional lights. It's just not something that the circuit gives a crap about. So, or I can connect this one. Now, again, to be fair, this one should be connected after the meter so that we can fairly evaluate. And all my tests have been done after the meter. As I said, it's just for convenience. I'm putting it on this side because that side is a mess. If I try to get it anything near this magnetic array, which is, it will not be in the schematics, I'm still testing whether that even has any effect at all. Everything in your local environment does. If I touch this meter, I can diminish the light output. Right, so if anyone says no, it doesn't have an effect on it, they don't know what they're talking about. But yeah, I find that's interesting. It's definitely a different source of power. I've put it on the meter on the oscilloscope, and she's weird. It looks like a frequency I've never seen before. It's very different. Again, appears low voltage, but when you connect up 6 volts worth of lights, when it says it only should not even run one, and then 12 volts as well. So very interesting. With the setup I will place on the schematic, it will be for the power factor version that gave me 0.9898. All right, so if anybody, now I've been messing around with this, so the power factor won't be actually correct because there'll be higher peaks and that sort of stuff in here, just because of startup and that and so on. So yeah, so you can look at those power factor numbers there, but in my opinion, let's see if we can get it restarted with new numbers. Okay, light on, battery regeneration or battery recharge connected, and so these are the numbers. You can work out the power factor from this sort of stuff, and just keep in mind that actually what you're seeing there won't be it won't be the 0.9898 because that included this coil in series with these coils. So, but I'll put up the best the circuit diagram, the schematic that relates to the 0.9898 power factor. Again, people, don't get bogged down in that. That's just a bunch of mathematicians trying to explain shit that they can't understand. So you don't need the math. It doesn't need to be done that way. You can be a complete idiot and do this stuff, as probably I proved, but you can literally just get wires and bunch them up like coils. You know, there's so many different variations that I've tried. I'm just looking for some, like here's a different coil here. You know, like in no way is that the same dimensions as those coils. You know, like no way, but still works. There are a whole heap of other coils that I've got that work the same way. This coil works. You know, again, it doesn't work unless my circuit's being run. If you just ran a normal DC light on that, that would not operate. So, rules are for fools, in my opinion. Alright, thanks for watching. Please like, share, and subscribe. Have a nice day.